Today, we're going to continue analyzing functions and graphs. It's kind of like just a big review of a lot of the vocab and techniques that we've been using. So I'm going to start with just a couple of basics. So let's talk about domain, range, for what interval of the domain is increasing and what interval of the domain is the function decreasing. So the Edpuzzle is going to stop you in some places, but in other places you might want to pause the video so you have thinking time. So the first, what is the domain of this function? Did you say everybody, right? So you can put in any x, you can input any value for x, and you can see it on the graph that this keeps going forever in this direction, this keeps going forever in that direction, and you kind of see that all x's can be put in. What is the range? Now the range, it is not everybody that comes out. So if you kind of turn your head, notice that none of these negative values are going to come out of the function. The first y that comes out is -2 inclusively, and there should be a bracket there, and it goes to infinity. Okay, for what value or interval rather of the domain is the function increasing? Now stop and take a look and think about that one. So in this domain, for what value, I want you to pretend you're riding left to right, just like you read, you're riding this function on a sled or a bicycle, and see how you're going down? This is decreasing. And right at this point, we turn around and we start going uphill, left to right. So this piece right here is the increasing piece. Now look at what interval of the domain. So we're asking for what x's. So we're going to start right here at -1. And then all x's from that point on would be increasing. And I believe that that should be a parenthesis, but we could have an argument. Does this point, is it included on the decreasing piece or is it included on the increasing piece? And I accept it either way for this, not for the domain and range, but for increasing, decreasing. Now for one interval of the domain is the function decreasing. And did you put from -infinity up to that -1? So this piece right here is the decreasing piece. A lot of people get confused because the arrows are like, well, it's pointing up this way. You're writing the function left to right. And if you're going down, that's decreasing. And if you're going up, that's increasing. So here are two that I put on here just to remember domain and range again, just a quick review. So how about the domain and range on 5? For the domain, did you put everybody once again? So every x value can be inputted. Now what comes out of the function? Did you put -1 to +infinity? And the -1 should have a bracket there because he is part of the range. I wanted to get this one on here because we had a lot of questions about, is there ever a domain other than everybody? So take a look at this one and do the domain and range here. So for the domain on this one, it is not everybody because you cannot put a negative under that square root. So the first number you could put in for x's would be a 0, and that would be inclusive with a bracket. And you will get up to infinity, as you can see, going this way. Now, what about the range? Well, the range also bottoms out. Its minimum value is 1. And goes up from there. Again, a bracket is necessary. So I just wanted to show you one that doesn't have that domain of everybody. Okay, we're back with our buddy Biff. And Biff is going to go on a jog. And I want you to look at this distance graph and pull off rate. That would be speed. So can you find his slowest rate? What is his fastest rate? And for what interval did that fastest rate happen? So pause the video if the Edpuzzle doesn't stop, please, and try to answer those 3. Well, the slowest rate would have that sort of shallowest slope. The steepness would be the least. He travels the least amount in the most time kind of idea. And you'll see that it's happening right here. So other than 0, as you notice there, he goes right here 100 yards in 2 minutes. 100 divided by 2, he's going 50 yards per minute. And you can tell just by the steepness, or rather how shallow that line is, that that is his slowest speed. Now, on the other way, we can see this is the steepest part, but I have to warn you, right here, he goes from 100 to 500. That's 402 minutes. 400 divided by 2 would be 200 yards. That is his fastest speed, but that's not the only place he does it. If you look right here, he went from 300 to 500 in 1 minute. That's 200 yards. And he also did it right here. So he went from 1 to 4 doing 200 yards per minute, and also from that 6 to 7. All right, it's Tuesday, Biff. Wake up. So now what is Biff doing? Start off with, what is the y-intercept? Did you put 800 yards, or 0, 800 is the point, the coordinates? What does it mean in terms of Biff? His starting distance from home was 800 yards, so he's already away from home, 800 yards away from home. What is the x-intercept? Did you put the 10, 0, or 10 minutes? What does that mean? Biff takes 10 minutes to reach home from that starting point of 800 yards away. So the y-intercept, the x-intercept, and what do they mean in terms of the graph? For what interval of the domain on Wednesday is the function constant? Let's give that an interval notation. Did you put from 4 minutes to 7 minutes? And again, when we're talking about constant increasing and decreasing, I tend to go with the parentheses, because this inflection point, which does it belong to? So I just kind of leave it out. If you did put a bracket on this one, though, I don't get too fussy. What does this represent for this 4 to 7 minutes? What is he doing? He's not changing. It's not, his distance from home isn't changing. He's not moving. So maybe he took 3 minutes to tie his shoe. I can't believe he would tie his shoe that long. He's chatting with a friend or something. Answered his phone. Thursday. Hey, Biff, wake up again. Wow, this is weird. Okay. What is the range of this function? Did you put from 0 to 400 yards? That is your minimum y and your maximum y, and it should be brackets. So now, what the heck is Biff doing here, right? I mean, why would he be going there? Distance from home, closer to home. Further away from home, closer to home. Anybody have any thoughts about that? He could be doing a loop, like going around I don't know if he'd be going around a track in that amount of time, but he's going around in a loop, so he gets away from home and comes closer to home, and away from home and comes closer to home. What remains constant during this entire jog? What you should have noticed is the steepness of the lines, which would give you his speed, his rate. So if you notice, he went 400 yards in 2 minutes. That's 200 yards per minute. So his speed, every single piece, he's going the same rate. He's running at the same speed. For what interval of the domain is the function decreasing on Friday? This is kind of an about, right? Whoops, sorry. This is an approximate. Man, I got to get back on my thing. Sorry. It's a Friday brain. 7 to about 7.5, and that's kind of a guesstimate. And again, because it's an interval, I tend to go with the parentheses because of those endpoints, right? What does this mean? Biff is moving back towards home, right? And it took him a half a minute to do that. What is the y-intercept? Did you put the 200 yards, which is the 0, 200? And what does that mean? He started 200 yards from home, moved away from home, stopped, and then went back to home quite quickly there. Last one, Saturday. Give one interval on the domain that Biff drove at a constant speed, and it will be an estimate. One interval, you've got some choices here. So notice that this time it changed to a speed graph. Did you catch that? So now in interval, these flat lines are constant speed where he's actually moving there. So you could have picked any one of these little portions, and then you're looking from the X. And the reason that you're not going straight vertical up, this is kind of an acceleration piece. It would actually be kind of a bit of a curve, to be honest. But you have that kind of, you don't immediately go from 0 to 20. There's that acceleration piece. So it's a little bit of an estimate here. So I'm saying, 0 to 1, definitely with parentheses there because it doesn't start exactly at 0. It also happened between 1 and 2. Again, a little bit less, a little bit more than 1, a little bit less than 2. From 2 to, about 2.5. And from that 2.5 to about 4. And again, we know that there's some time in there that's accelerating, or eventually over here, we would be talking about decelerating. And about how long did Biff drive at 50 miles per hour? And it's about, whoops, here we go again, Mrs. Woodruff. You're messing up left and right today. And that would be about an hour from 1 to 2. Here's your 50 right here, and it's just under an hour that he drove at 50 miles per hour. So basically, we're just trying to get comfortable with some terminology and reading speed graphs and distance from home graphs, understanding how to get speed off of a distance graph, understanding increasing, decreasing, domain, range, x-intercepts, y-intercepts, constants. All those ideas are kind of what we're talking about today. So now we're going to get to do some practicing. And pretty much we'll be heading for a quiz on what we've learned about functions so far. Guys, I hope you have a great day.